Hey everybody, this is Larry. This is January 20th. I'm doing Leetcode personal Larry challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this poem. Usually I pick a random one, and I did actually pick this as an RNG, but then I was like, oh, let's solve the previous poem first. So you may have seen, if you were looking for it, you could see the link for the first poem first, and then now let's actually read this poem and actually solve this poem. So let's jump right to it. So we know what a max tree is. We have construct. What are we supposed to do? What am I doing? What is the difference here? Okay, if A is empty, we turn no. Greater, we know the left is going to be construct. Okay, the right node is Huh? Is this like a add a value thing? Suppose B is a copy that. Oh, I see. I didn't read this part. There's just so much definitions, and then this is the actual problem, which is that, okay, suppose we have, so that means that you have this list. I mean, they don't give you the list, they give you the tree, and then you have this list, and then now you have to try to figure out, sorry, whoops, this is the thing, I guess. So now you have these two lists, and you try to figure out, but you're only given the tree of A, and then now you have to try to get tree of B, right? Okay. Where you have value, okay. Huh. That is an interesting problem. But it also seems like it's going to be a mess, to be honest. But where B is the root. Are there multiple? I'm trying to think whether I think the solution would be unique. I don't think this is. Yeah, it should be deterministic because it's just based on the locations, right? So okay. I honestly I do not have an immediate idea right now. So okay, so let's say we have this tree. You have a 5, right? Well, 5 would just go to the root because 5 is bigger than all the numbers. But it'll be on the left side, or it'll be on the left node for that reason. Okay, fine. Here you have a 3. So okay, so the first thing to note is that if it is smaller than, and this is going to be done recursively, if it's smaller than the root, then what happens? If it's small, or if it's bigger than the root, then, well, it just goes on the thing. Otherwise, if it's smaller, it always goes to the right side because that's how the partition works, right? So we always go to the right. Okay, let's say, okay. I mean, the way that I always play about it is that, let's say we have this thing, and then now we insert 3, we have this answer. But what happens when you insert, say, 4.5, right? When you have a 4.5, then now it goes, so basically you keep on going to the right until you find a node that it is bigger than, right? And if it's bigger than, then now you substitute it, and then it'll be on the left side. I think that's right. So okay, so that's not that bad, but we still have to say it, right? So now, okay, so let's just say, okay, so the way that I want to start this is actually by creating a sentinel value, right? So we have a sentinel. It's going to be a tree node. We have some infinity value so that it always goes to the right side with the rest of our algorithm. So infinity, we have none, and then the right side is going to be, maybe I'll write it more explicit this way. I like it to write it this way instead, is you go to the root, right? And then now current is equal to sentinel. So then now, what we want to do is, and we only want to use the pointers. So okay, so while current dot right is not none, we might have to consider what it means to be none. If it's none, so we go to the right because it's on the right side. If it's none, then you just put it to the right. Okay, fine, right? Yeah, that makes sense. basically if you have this and you're inserting 3.5, the 3.5 would be to the right of the 3, right? Yeah. Wait, no. I meant 2.5. That's what I wanted to say. But if it's 3.5, then it would replace the 3 and then it squeeze everything else to the left. Yeah, okay. Yeah, so then now, okay. So if current.right.value is greater than value, and these are all unique, right? Unique and value, is value unique? I want to say that they're not precise about it, but it probably is. Otherwise, it would just be tricky. Okay, so if the value is greater than that, then we go to the right. So in this case, current is equal to current.right, then we continue. Otherwise, I guess I don't need to continue explicitly, but I like to do it so that if I change the code structure a little bit, it'll still work without thinking about it. But okay, so if it's less than, then now we're done, right? If it's less than, then we actually want to set current.right. Okay, so previous right is equal to current.right. And so that's the node. And then current.right is going to be equal to a new tree node with the value. And then this current.right.left is equal to the previous right and previous right. And then we can break and maybe even return actually. Yeah, we can actually return sentinel dot right. Otherwise, current.right is none, so that means that we can just set it to current.right. So current.right is equal to sentinel. What am I doing? Tree node of value, and that's pretty much it. Because there's nothing there, so you don't have to replace anything. So we can actually maybe even set this. This is generally true, so we can actually break and then maybe do this, but it's a little bit awkward. And also, to be honest, during a contest, I don't like to do this just because. Oh no, this is right. Yeah. Just because like it's just more things to prove. I don't know, but yeah, Ben, you can obviously condense this a little bit. I mean, you are here, you followed the logic, so yeah. So, but you can also promote this to something like this, right? And yeah, let's give it a submit. Hopefully, I didn't miss an edge case, and we're good. Obviously, I say obviously too much, but. Yeah, for complexity though, this is going to be linear time, linear constant space, linear time coming from, we have to go, if it's a linked list E tree, you have to go through the entire linked list of tree. And space, we only really have 2 variables, right? The sentinel, the current, and that's it. And we allocate only 2 extra nodes. And we just kind of manipulate the pointers, and it's in place kind of, which I think is fine with this one. I mean, if you really want to you can make a copy of everything. It'll just be, you do a depth first search or something if you, a tree traversal. But yeah, that's all I have for this one. I don't know why there are so many downvotes, and I guess it is an interview question. But I think the difficulty is about right for an interview, though it is a little bit trickier and easy to get wrong. But yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.